Hello to everyone. Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today we are going to discuss the topic about on the Fourier series of the neither functions in a given interval. The length is minus pi comma pi. Before going to discuss here the Fourier series under the neither functions, the limits are under the minus pi comma pi, we need to discuss first of all how to identify that is even function, odd function, neither function. And after that we need to discuss some of the basic integration parts. Then after that we'll go to discuss how to find this is the topic. Here for example, even function. According to the even function, whenever the given function is satisfied, if f of minus x is equal to that is f of x. That means a function is said to be even function, f of minus x is equal to f of x is said to be the even function. And if f of x is an even function defined in the interval minus a comma a, for example, in branch of here minus a comma a, either it may be minus l comma l or minus pi comma pi, whatever it may be. Here assume that if it is the limits are under the minus a comma a, and moreover the integration is in between the limits are minus a comma a, the function that x into dx is equal to here the 2 into integration 0 to a f of x into dx. And the graph of that example of the even function, for example x square, x power 4, x power 6 and up to so on x power n, where n is an even function. That means, for example, if it is a consider x square is any one function, that means it is treated as f of x is equal to x square. And by the definition, when you are going to replace at x is equal to minus x, that means minus x of whole square is equal to that is x square. This is the meaning of the function is an even function with the help of f of minus x is equal to that is a f of x. And the every constant function is an even function. And the graph of the cos x and is the graph is symmetrically about the y-axis. For example, here the graph is if it is a function is even function, it is automatically graph is a symmetrically about the y-axis. For example, if you are going to observing here x-axis and y-axis, the function is f of x is a mod x. If you are going to observing here, mod x is always it is a even function. Even if you are going to observing the graph of the even function of this one, it is clearly showing the symmetrically about the y-axis. That means you by taking any even function, if you are going to draw the graph, it is clearly showing the parallel to that is symmetrically about the y-axis. And next coming to odd function. Similarly, whatever we discussed in the previous, that is f of minus x is equal to that is f of x is even function. And here the odd function is nothing but whenever the function is said to be f of minus x is equal to minus f of x. That means a function is said to be that is odd function f of minus x is equal to minus into f of x. Here f of x is an odd function defined in the interval minus a comma a is equal to it is automatically the value is 0. That means the function is clearly the limits are in between minus a comma a, the value is 0. And particularly moreover here f of x is the odd function. And in the previously it is a even function is minus a comma a, that f of x into dx is equal to that is 2 into integration of 0 to a, that f of x into dx. And here particularly that f of x is in this case it is a 0, that means provided it is a even function and it is a odd function. These are the basic fundamental the properties under the even function and odd function whenever the limits are minus pi comma pi conditions. And for example, here the functions are for example x, x cube, x power 5 up to so on x power m, where here m is a odd function. For example, it is also treated as f of x is nothing but it is x And while we are going to replace f of that is a minus x is equal to clearly it is a minus x. And minus x is nothing but minus into f of x is a function. And for example, if it is a consider x cube, that means that is f of x is equal to that is x cube, and here f of minus x is equal to minus x whole cube, and here minus into that is f of x is the condition. And this is the clear information regarding the a function is said to be odd function, that is nothing but f of minus x is equal to that is minus x. And here the graph of the sin x is a aeronautical about the origin. And whereas in the previously the function is a even function, the graph of the even function is always symmetrical about the y-axis. But whenever the function is an odd function, the graph of the odd function is always parallel to or something symmetrically about the origin. For example, it is a graph of this function. This is under the x comma y. If you are going to observing here, it is a y is equal to x. That means f of x is equal to x. And here clearly x is a passing through the origin. That means according to by the statement of here, the graph of the odd function, it is passing through the origin. For example, the function is like this. It is the graph of the function is x cube. That x cube is nothing but here also passing through the origin. And next one, graph is a for example x power 5. And x power 5 graph is also clearly showing according to like this. And moreover, it is also passing through the origin. And similarly, like any function is given, the function is a graph of the odd function is automatically passing through the origin. And next one, coming to point, that is a neither function. The neither function is nothing but it is a different from the even function and odd function. Whereas the function is a even function, that is a f of minus x is equal to f of x. That means it is even function f of minus x is equal to f of x, and odd function is a f of minus x is equal to minus f of x. But here neither function is nothing but neither the even function nor odd function. That means that f of minus x is not at all equal to either f of x or that is a minus f of x is a condition. Such type of the functions are known as a neither function. That means, for example, these are the some of the example for the neither function. For example, it is a e power ax if it is a consider. And here, if it is a e power ax is a given function, for example, f of x is e power ax, and by the definition, if you are going to replace f of minus x is equal to, it is e power of minus ax, and it is not at all equal to f of x or not at all equal to minus f of x is the condition. It is not satisfied. Therefore, such type of this function is a neither function. And other example, it is x plus x square. And here also, if it is replaced that x is equal to minus x, that is minus x plus minus x of whole square, and is equal to, it is a minus x plus x square, and it is not at all equal to x plus x square or not at all equal to that is minus of x plus x square. That means it is clearly by observing this is also one of the simple example for the function is a neither function. And here ax power m and bx power n, it is also the depend upon the even function and m is odd function. It is also clearly the function is a neither functions. Next, coming to point Leibniz formula. That means before going to discuss under this is the Fourier series, that is even odd neither function, we need to understand that is a basic formulas for the integration by parts. And one of the major important the formula is a Leibniz formula, that is integrating by parts. We need to understand what is the integrating by parts. Here, for example, integration of uv dx is equal to, this is the general nth formula integration by parts. It is the integration uv is equal to uv1 minus u dash v2 plus u double dash v3 minus up to so on. This is the integrating by parts in general formula. And here, otherwise, in presence of uv, it is a udv. That uv dv is nothing but Same like that, uv minus u dash v1 plus u double dash v2 plus minus up to so on. Either we need to follow any one of the formula integration uv or integration udv. Here u dash, u double dash up to so on are called as a, that is a derivative functions. Whatever it is a u, that u dash is the first derivative, u dash is the second derivative, and u triple dash is the third derivative. And from v, that is a v1, v2, v3 are the integration parts. That means whatever we assume that v, that v1 is the, that is integration one time, and v2 is the two times integration that depend upon the number of infinite integration parts. And here the choice of u and v is as per the Liet or Eilets. Here either we need to follow the Liet or Eilets. When we are going to do that integrating by parts, that is a Leibniz formula, we need to give the priority by using the Liet. And what is the meaning of Liet? And here that L is nothing but that is a logarithmic words. The logarithmic is nothing but like according to log x. And again that I is nothing but inverse function. That is nothing but it is invertible. That examples are sin inverse x, cos inverse x, and tan inverse x. Like these are the inverse functions. And other one, that is a A. A is nothing but algebra. Algebra is nothing but it is a function is a in terms of x. That A is a algebra. That algebra is nothing but in terms of that x, that is x square and x like pi minus x and x square pi. Like these are the some terms. And next one, that is a T is nothing but that is a trigonometric. And trigonometric is nothing but like sine, cos, tan, secant, cosecant. Like these are the trigonometric functions like sine, cos, and up to so on. And next one is a E. E is nothing but that is exponential functions. Exponential is nothing but that is based upon the E terminology. That is e power x and e power minus x, like any one of the functions. For example, based upon the integrating by parts, how to do that? For example, these are the, if it is considered, it is not required this one actually. Here, x power 4. These are the some basic differentiations and integrations. First x power 4 is a derivative is 4x cube, and again the second derivative is 12x square, and again that the next is 24x, and after that 24. And again here x power 4 integration is x power 5 by 5. And for example, coming to point, that is a cos x, the integration is sin x by a, one time integration, and one more time integration minus cos ax by a square, and the other side that is a minus sin x by a cube. These are the successfully one by one integration parts. And again, for example, sin x integration is minus cos ax by a, and one more time integrating, that is a minus sin ax by a square, and other time integration is cos ax by a cube, and again similarly so on, that is increasing that depend upon the sine to cos and again cos to sine, like that depend upon the coefficients of the x value. These are the some basic integration, basic differentiation for the, it is useful for the integration by parts. And based upon here the Leibniz formula, for example, integration of x square sin x based upon the integrating by parts Eilert or Liet. If it is a consider, it is the first one is a u, and second one is a derivative is according to by the formula u2, u dash is a 2x, and one more time that is a second derivative, that is a two conditions. And again after that there is no differentiation is required because of two derivative is a 0. And after that coming to point v1, that v1 is a sin nx is the v, that v1 is a, that is a minus cos nx by n, and v2 means one more time integration minus sin nx by n square, and v3 that is integration part one more time, that is a cos nx by n cube, and further it is not required. And this is the integration of sin x square into sin nx is the by using the Leibniz or something Eilert or Liet is the priority. Now this is the final solution of the integrating by parts. For example, exponential functions. The integration by part exponential function is based upon, as we know that, e power ax by, that is a square plus b square into a sin bx it is minus b cos bx is the value, and again plus c is the constant term, and integration of e power x into cos bx dx is the e power x by a square plus b square into a cos bx plus b sin bx is the value, plus additionally c is the constant terms. And similarly, one example, integration of e power to x into sin to x into dx is the here where a is the 2 and b is the n value, and based upon here the value is e power of 2x by that is a 2 square plus n square, and into that is a 2 into sin nx minus n into cos nx is plus c is the constant terminology. After that simplification, this is the final solutions. For example, for any like these are also important to remember under the Fourier series, the basic formulas. For all values of cos 0 is equal to 1, like sin 0 is also 0, and cos n pi is equal to for all values of minus 1 all power n, and sin n pi is equal to always 0, that based upon that n is equal to any number of values, sin is n is equal to 0, n is equal to 1, n is equal to, for all values of sin n pi is 0, and here the cos n pi is equal to minus 1 all power n, because of based upon that, for example, n is equal to 1, the cos pi is equal to minus 1, and n is equal to 2, that is a cos 2 by the value is a minus 1 whole square, that will goes to that is a plus 1, and similarly like that. And similarly, cos of 2n plus 1 into pi by 2 is a 0, and again sin of 2n plus 1 into pi by 2 is equal to minus 1 whole power n. These are the some basic formulas or basic values we need to remember for the purpose of it is a Fourier series, while we are going to discuss that is a neither function and including the even function and also the odd functions. And again here keep in mind that is a f of x is an even function under the limits are minus L to L. Already we discussed whenever the function is even function, that is a limits are changed to 2 into that is a 0 to L into f of x into dx, and it is very important to remember it is a 2 into f integration 0 to L f of x into dx, and moreover the function is an odd function. Here the integration minus L to L, the value is equal to that is a 0. Based upon this one, here under the Fourier series, the types of the intervals, here the types of the intervals are basically dividing into that is a two types. One is limits are under the 0 to 2 pi, and again second one is a minus pi to pi. But these are the both are the full range series. Here that 0 to 2 pi is the full range series, and minus L pi to pi is also full range series. Now we will go to discuss, before going to discuss the minus pi to pi, here what is the trigonometric series, what is the Fourier series like. And again here let f of x be periodic function with period 2 pi defined in the interval c comma c plus 2 pi can be expressed as a trigonometric series as that f of x is equal to a naught by 2 plus n is equal to 1 to infinity a n cos nx plus b n sin nx is the value, where the values are a naught is equal to here the is known as a Fourier series, and again where a naught, a n, b n are called as a Fourier coefficients of f of x, or it is also sometimes called as a Euler coefficients of f of x is the value. And where the value of a naught is equal to 1 by pi integration c to c plus 2 pi f of x into dx, and a n is equal to 1 by pi integration c to c plus 2 pi f of x into cos nx dx, and bn is equal to 1 by pi integration c to c plus 2 pi f of x into sin nx is the dx. This is the Fourier series under the limits are c to c plus 2 pi. The values are a naught, a n, b n are called as a that is Euler coefficients or Fourier coefficients. And based upon here, it is a c is equal to replacement of that is a 0. You get the different type of the interval, and again that c is equal to minus pi. The limits are minus pi comma pi. And today we are going to discuss about that the limits are under the minus pi comma pi. That is a Fourier series. Here the f of x is the series is the a naught by 2 plus ms in n is equal to 1 to infinity a n cos nx plus b n sin nx, under the limits are minus pi comma pi, where the value of a naught is equal to 1 by pi integration minus pi to pi, that is f of x into dx, and a n is equal to 1 by pi integration minus pi to pi f of x into cos nx dx, and again bn is equal to 1 by pi integration minus pi to pi f of x into cos nx sin x nx into dx. These are the a naught, a and b and are called the Fourier coefficients or Euler coefficients. Under the limits are minus pi to pi, it is a Fourier series for f of x is equal to, this is the clearly representation. Now we go to discuss under the minus pi to pi, the function is a neither function, what we need to find out. Whenever the function, like the limits are minus L to L, the function is a neither function, here compulsory we need to check what is the value of a naught, an and bn. It is a compulsory mandatory. But in case the even function and odd function we discuss as in the previous lectures, the Fourier series or limits are minus pi to pi, even function and odd function. But today class we are going to discuss the limits are minus pi to pi, that the function is a neither function. We concept is to find out only the values are a naught, an, bn is the values. Based upon this is the Fourier series and the Euler's formula a naught, an and also bn we need to find out. And after finding that Euler coefficients, then you need to replace in the required Fourier series, that is a f of x. Here, for example, neither functions. Here, we need to remember in this neither function, whenever the function is, that is f of minus x is equal to not at all equal to f of x and not at all equal to minus f of x is the condition. Based upon this one only, we need to go to further the proceeding, that is a neither function, identify, and again based upon the formulas a naught, a and bn, we need to find the solutions. Here, according to here, this is the required to find out. For example, find the Fourier series represented e power x in the interval minus pi comma pi. Here, simply they are asking to find out the Fourier series. The limits are, we need to observe minus pi comma pi. Here, the other thing is, what is a given function? These are the three things we need to remember. What is the basically what is the limits under the, and again what is a given function. And based upon the given limits, the limits are under the minus pi to pi, we need to identify whether the function is even or neither. And here, the function is clearly e power x is the neither function. Because of, for example, f of x is equal to, if it is assumed e power x, and f of minus x is equal to e power minus x, and which is not at all equal to, that is f of x, not at all equal to minus f of x. Therefore, the function is said to be neither function. If it is a neither function, our concept is like target to find the series, the required Euler's values are a naught, an, bn is a value. And where that is the meaning of here, that is a c to c plus 2 pi, that is a c is equal to minus pi to pi. By observing all these conditions, the limits are, it is a periodic function is f of minus x, that is a minus pi comma pi. Here, the required series is f of x is equal to, this is a series, and where a naught is equal to 1 by pi integration minus pi to pi f of x into dx, and an is equal to 1 by pi minus pi to pi integration f of x cos nx dx, and bn is equal to 1 by pi integration minus pi to pi sin f of x into sin nx into dx. By using these are the Euler's coefficients, with the help of the given function, you need to find the solutions. Here, for example, first we need to find out the a naught value. Here, a naught is equal to, we know that given the formula 1 by pi integration minus pi to pi f of x dx. Here, given function is f of x is equal to e power x. That means we need to replace in the e power x. Here, not possible to change like 2 into integration of 0 to pi or integration of any other conditions, because of the limits are under the minus pi to pi. Therefore, it is not possible because of the function is a neither function. Therefore, we need to do the directly integration e power x. The integration e power x is equal to e power x as it is. The limits are, it is minus pi to pi, while we are going to replace that upper limit is pi and lower limit is minus pi. The value we change it to e power pi minus e power minus pi is the value. And this is the value of a naught is equal to the value e power pi minus e power minus pi by pi is the solutions. And similarly, we need to find out other Euler values, that is an and also bn. Similarly, it is an value. An is equal to 1 by pi minus pi to pi integration f of x into cos nx dx. And here, given the function is f of x is equal to e power x, therefore 1 by pi integration minus pi to pi f of x, that is e power x into d cos nx dx, because of it is already existed formula. And here already we am given the formula integration e power x into cos b x. By using this formula, here a is equal to 1 and b is equal to n. With the help of here, we need to replace in that formula 1 by pi integration. The value is e power x by, that is 1 square plus n square into that a cos nx, that a is nothing but 1, that is 1 into cos, that is nx, plus b is equal to here n, that is n into cos nx is the value. The limits are under, that is minus pi comma pi. And 1 by 1, after that of replacement of, that is x is equal to, that is a pi, that is 1 by 1, the value is here. The first upper limits are, that is e power pi by 1 square plus n square into here cos nx. Already we know that cos nx is the cos n pi formula is a minus 1 over n, and the lower limit here, that is the upper limit is sin n pi is the value is 0. And similarly, the lower limit, that is e power minus pi by, that is 1 square plus n square. And again here also cos, that minus of n pi, that is a cos n pi. Again here also minus 1 over n. The lower limit is also 0. And here based upon these two equations, we need to take out a common e power 1 minus 1 over n by, that is a pi into 1 plus n square into, that is e power pi minus e power minus pi is a value. This is the clearly the value of an is the value. And similarly, we need to find out one more, the Euler's values, that is bn, where bn is equal to, as we know that 1 by pi integration minus pi to pi f of x into sin nx dx. And here also we know that f of x is equal to e power x, therefore 1 by pi integration minus pi to pi e power x into sin nx dx. And here also, as we know that according to integrating by part formula, integration of e power x into, that is sin bx dx, here e power x by a square plus b square into a sin bx minus b cos bx is the value. And here in this problem, that a is the value is 1 and b is equal to n is the value. By using these are the two values, when you are going to replace in the formula, the problem is changed to 1 by pi, like first part is e power x by, that is 1 square plus n square into, that is 1 sin nx minus n into cos nx. By replacement of here also the upper limit as well as the lower limit, here 1 by 1 the successfully, that is a 1 by pi into, the upper limit is e power of pi by 1 plus, that is n square into, that is upper limit sin n pi is the value 0, and again the cos n pi is a minus 1, and based upon this one, it is a minus into minus 1 whole power of n is a value. Because of this term is a 0. Based upon the n sin n pi, and again sin of n minus pi is also the value is 0. Minus the lower limit by replacing e power of minus pi by 1 square plus n square into, and here also the lower limit is also clearly sin of n minus n pi is also 0, and again cos of n minus pi is also something minus 1 whole power n is a value. And after that simplification, here clearly we are getting that minus of n into, that is minus 1 whole power n by, that is a pi into, that is 1 plus n square, take out common, and again the rest of the thing, it is a minus 1, that is e power pi into minus e power of minus pi is a value. And these are the clearly the Euler's coefficients with the help of the given function under the neither function, that f of x is equal to e power x is the value. And after getting these are the a naught, a and b n, here our required Fourier series is f of x is equal to, while we are going to replace all this value, we get clearly that is f of x is equal to e power pi minus pi by 2 pi, because of in this a naught value and a n value and b n value, that e power pi and e power minus pi by 2 pi is a common, because of 2 is already existed, and again the denominator it is also pi is available, and again the rest of the thing, that plus summation n is equal to 1 to infinity. This is the clear information. Therefore it is a final solution of the f of x is equal to e power x, then the function is a neither function under the limits are minus pi comma pi is the value. It is a simple good example for that. The function is a neither function under the limits are minus pi comma pi is the value. And similarly, for example like this, it is also find the Fourier series for the function f of x equal is a given by, it is the limits are under minus pi x, the limits are minus pi in the interval minus pi to 0 and x, the limits are under the 0 to pi. We need to find out what is the Fourier series, and after that you need to find the reduce the conditions. That means first of all here also we need to observe the given limits. Here also the limits are, the starting is minus pi, the ending is a pi. That means the limits are under, that is a minus pi comma pi is the limits. And here we need to identify what is the function, whether it is even or neither functions. And here clearly it is a, for first function minus pi to 0 is a minus pi. The second limits are 0 to pi, the function is x. It is clearly minus pi and also x, therefore it is a clearly it is a neither functions. For example, in place of minus pi, the function is, it is a minus x is given, and second function is x is as it is, the function is clearly, it shows the even function. But in this case, the function is a neither functions. And here, therefore, with the help of this is also neither function, here we need to find out a naught, an, bn, the category. And here also that f of x is the, clearly according to this the graph, it is 0 to minus pi to 0, the value is minus pi clearly, and 0 to pi, the graph of the function is clearly like this. Therefore, it is not a equal like the functions. And moreover, based upon this one, same like that, it is a function is a neither function. We need to find out according to a naught, an, and bn, where a naught is equal to, as we know that the formula 1 by pi integration minus pi to pi f of x dx. But here in this problem given the split into two parts, one is a minus pi to 0 and 0 to pi. And under the minus pi to 0, the values are minus pi, and 0 to pi, the values is the x. Therefore, based upon this one, here first one, while we are going to do that integrating like the two parts, one is a minus pi take out common and pi is a cancel. And again here the rest of the thing is minus x. The limits are under minus pi to 0. And again the second one, 1 by pi, here integration x is the x square by 2. Here after replacement of 1 by 1, the upper limit and lower limit, the first part is a minus pi, the second part is a pi by 2. Therefore, the solution is a minus pi by 2 is a value. And similarly, we need to find out what is a an. That an is nothing but, as we know that 1 by pi integration minus pi to pi f of x dx. And here f of x is nothing but the given function is a e power x into, that is a dx. Sorry, e power f of x is splitting into like the two parts, minus pi to 0 and 0 to pi. And in between minus pi to 0, the function is a minus pi. And in between that 0 to pi, the function is a x into cos nx. And it is also 1 by 1 integrating by parts. For first one, minus pi is the constant, take out common outside. Therefore, it is after take out common minus pi, the value is it is minus 1 integration minus pi to 0. It is a cos nx into dx. The integration of cos nx is a minus of, that is sin nx by n. The limits are, it is minus pi to 0. By solving this one, it is clearly the value is a minus 1 whole power n minus 1 by n square pi. And similarly, we need to find out finally that is a bn value. That bn is nothing but 1 by pi integration minus pi to pi f of x into cos nx dx. And here also the function is splitting like the two parts. One is a minus pi to 0 and 0 to pi. Here minus pi to 0, the function is given, that is a minus pi. And second one 0 to pi, the limits are, that is the function is a x. And here also by using the integrating by parts, you take out common minus pi is outside. The rest of the thing sin integration is a minus cos nx by n. And again after replacement of like getting that cos nx, that replacement of minus pi to 0, and again place together integration of 1 by pi integration 0 to pi, that x into sin x into dx, the integrating by parts, we obtain that clearly 1 minus 2 into minus 1 whole power n by n is the final solution. And here it is not at all completed because of in this problem they are required to ask like that, finding that Fourier series and also deduce the problem. That means whatever we know the f of x in this, we need to replace that, getting the values are a0, an and also bn. We need to replace that one by one in price of a0, an and also bn. While we are going to replace that a0 is a minus pi by 4 because of already existed, it is a 2. And again place summation n is equal to 1 to infinity an, that n is nothing but we know that 1 minus 1 whole power n by n square into pi into cos n pi plus bn, that bn is nothing but we know that already 1 minus 2 into minus 1 whole power n by n into sine, that is a nx is a value. And with the help of this is the equation, we need to deduce the problem. Here by replacement of this one, we need to prove this is the clear solution. While we are going to observing here, in the required series is in branch of that is a 2n minus 1 whole square. That means that is a for odd values. But in this series, here one side is a n, other side is a n square. That means while we are going to observing in this one, it is n is equal to 2n minus 1 is clearly required to satisfied. That means it is a remove that part n, because of it is a denominator is required the 2n minus 1 whole square only conditions. Therefore, due to that reason, let us put that x is equal to 0, automatically the second term it will be removed. Therefore, by replacement of x equal to 0 in the equation 1, that is a f of 0 is equal to minus pi by 4 plus summation n is equal to 1 to infinity, it is 1 minus 1 whole power n by n square pi into cos 0. That cos 0 value is a 1 value. Therefore, again by using this one f of 0. And here while we are going to observing at 0, the given function is existed in the mid of the part. That means LHS at 0 is the value is minus pi, the RHS limit is 0 is equal to 0. That means one of the at x is equal to 0 is a minus pi and right side value is a that is a 0. Therefore, the function is a discontinuous function. And if the function is a discontinuous function, we need to modify or reduce it to change it to that is a continuous based on the average of the LHS limit and RHS limit is a value. That means at x is equal to 0, the value of the given function minus pi by 2 is the value. Therefore, this minus pi by 2 can be replaced in place of f of 0 is equal to that is a minus pi by, like f of 0 is a, yeah, it is minus f of 0 is a 0. Yeah, okay. X is equal to 0. Okay. Based upon this one, it is a minus pi by 4 is equal to 1 by pi. F of 0 is the, sorry. Yeah, it is a x is equal to pi. Yeah. It is minus pi by 2. I think it is a minus pi by 2 is the value. And based upon this is clearly it is a 2. Yeah. 4 minus 2 pi by 4. It is minus pi by 4 plus 4. Take the LCM 4. And again that 2 minus 2 pi plus pi, it is a clear. Something we need to check it. Yeah. It is a clearly pi square by 8 is equal to 1 by 1 square. Therefore, finally, it is in the form of the denominator, clearly showing it is a 2n minus 1 is a whole square is a problem. Similarly, any problems are given, we need to follow with the help of this is the neither function based upon the given limits are under the minus pi to pi. We need to identify the function is a neither functions.
Like, share and subscribe. Hit the bell icon for more updates.